Okay, in this video, we have a scenario here, so a word problem scenario, and we want to calculate the rate of change or the constant rate of proportionality. We want to make an equation, and then we want to use that equation to answer some type of math word problem. So question 3 says to complete the table and sketch a graph of the relationship between inches of rainfall, y, and the number of hours, x. So usually, again, when you see a table, the first row or column is x, the second row or column is y. So the total amount of rain will depend on the hours that have gone by. This over here is our x-axis and our y-axis. When it's a word problem, we want to label our graph. And what that means is label it the units here. So down here, this would be number, and I'm looking here, number of hours. And our y-axis is inches of rainfall, total rainfall, yep. So I'll say total rainfall, and let's get those units in there. Inches is IN. So right now, this is called labeling our axes. So we just labeled our axes, done. So the next thing we want to do is calculate the rate of change. Now we're only given a table, so how do we do that? So rate of change, remember this is our constant of proportionality. Which is calculated with k is equal to y divided by x. So we have 2 points in the table and we want to make sure that they're both the same value. So our first work would be 10.5 divided by 3. So what does that equal? And then we need to calculate 17.5 divided by 5. So let's do one of those together in this video. So 3, how many times does 3 go into 10.5? Well, 3 goes into 10 3 times, that's 9. 10 minus 9 is 1. 3 does not go into 1, so I'd like to bring down that 5, but there's a decimal here, so I need to make sure I put it in the answer, and now I can bring down the 5. 3 goes into 15 5 times. So this goes into a perfect number, 3.5. And you can pause the video and go ahead and confirm the same. For 17.5, you'll also get 3.5. So again, this is good that we're getting the same constant of proportionality. We're getting the same rate of change. So this is part 1 of my answers. And the second thing is explain its meaning in context of the situation. So what this is telling you is so actually this is your unit rate as well. So that means that this is 3.5, okay? So I'll draw an arrow and remind you that this is your unit rate. And that also means that this is your K value. So in 1 hour, there will be 3.5 inches of rainfall. Or each hour, the amount of rain increases by 1 inch, however you want to write it. So, let's see, yeah. The total rainfall increases by 3.5 inches each hour. Can you squeeze that in? All right. The total rainfall increases by 3.5 each hour. How do I know it's increasing? Because this is a positive number. If it was negative, I would say decreasing. Can you make an equation now? Okay. Well, k is 3.5. Remember, an equation, a general equation is y is equal to kx. So our equation here is y is equal to 3.5x. Done. And how many inches of rain will fall after 6 hours? Which variable is this? How many inches of rain? Hours, inches of rain, right here. That's my y variable. So this is asking for y when 6 hours. That's my x, when x is 6. So I have a game plan. I'm going to use my equation to calculate this. So if I write y is equal to 3.5x, I'm wanting to calculate y when I know x is 6. So I will substitute 6. 3.5 times 6. Let's practice that decimal multiplication. How about I do that over here? 3.5 times 6. So 6 times 5 is 30. 6 times 3 is 18, plus 3, 18, 19, 20, 21. Count my decimal over. So this gives us y is equal to 21. But this is a word problem. So I've now shown this is what it looks like when it says use your equation to calculate this answer. So we just did that. And now we need to answer this question. How many inches of rain fall after 6 hours? So after 6 hours, there will be 21 inches of rainfall. And so now I can actually go back and fill in the table and make the graph. So filling in the table, there's a couple of ways that we can use this constant rate of proportion. So we could, since our x values are increasing by 1, we could add 3.5 and we would get the next one. So 3.5 plus 3.5 would be 7. And double check that this is right. If I add another 3.5, do I get 10.5? 7 plus 3.5 is 10.5. So yes, we could keep adding. This would give us 14. And 14 plus 3.5, does it give us 17? Yes, it is, 17.5. So you can keep adding the k value, plus k, plus k, plus k, plus k. You could also use the equation. 3.5 times 2 is 7. 3.5 times 4 is 14. So you could also use the equation. I've seen it both ways. I've taught it both ways. How do we make our graph? Well, we have to have a table first before we make a graph. So we have 1 and 3.5. Now, you might have to estimate where that is. So it's always best if you use corner points. That's a corner point. That's a corner point. And I know it's a corner point because it's a whole number. It's going to go through the graph at 2, 7. 7 is right in between 6 and 8. So there's for sure 1 point. 4 and 14. There's my second point. And where do proportional relationships start? It's always plus 0. There's an initial value of 0. That's what makes it proportional. So I would grab my ruler and I would connect my lines and I would draw an arrow because I could still continue this scenario. I want to make sure I extend it to the grid. And there's your graph.